What if I told you that rust, the enemy of metals, could actually be the key to the next generation of ultra-lightweight, high-strength alloys? Scientists have cracked the code on using corrosion, yes, the same process that eats away metals, to create futuristic materials that are stronger, lighter, and completely sustainable. No CO2 emissions, no energy waste. Just cutting-edge, revolutionizing alloy design. Stay tuned because what you're about to discover will change how we think about metal forever. Why traditional metal alloys are holding us back. For centuries, alloying has been the foundation of metallurgy, blending metals to get stronger and more durable materials. But there's a catch. Traditional methods consume massive amounts of energy, emit tons of CO2, and rely on expensive rare earth materials. And dealloying? That's just corrosion, a process that usually weakens and destroys materials over time. But what if we could turn that weakness into a strength? Corrosion reimagined. Enter the Max Planck Institute for Sustainable Materials. Their revolutionary idea? Instead of fighting corrosion, let's harness it to build better materials. How? By using a technique called reactive vapor phase dealloying. A high-tech process that selectively removes oxygen from metal lattices while simultaneously improving the microstructure. The secret weapon? Ammonia gas. It removes oxygen, stopping corrosion. It adds nitrogen, which strengthens the metal. One gas, two powerful effects, resulting in alloys that are lightweight, ultra-strong, and energy-efficient. How it works, the 4-in-1 process. This new method combines 4 powerful metallurgical processes into one single step. Oxide dealloying removes oxygen, increasing porosity and reducing ores with hydrogen. Substitutional alloying allows metals to mix and form even stronger structures. Interstitial alloying introduces nitrogen to enhance strength and stability. Phase transformation creates a martensitic structure, making the alloy ultra-strong at a nano level. This is like giving metal a high-tech upgrade at the atomic level. The biggest benefit, sustainable CO2-free alloy design. Unlike traditional methods that burn carbon and produce toxic emissions, this new approach is CO2-free. It uses hydrogen instead of carbon as a reducing agent. Energy efficient. One single reactor step instead of multiple complex processes. Eco-friendly. The only byproduct is water, no toxic waste. Cost-effective, works with impure industrial oxides, reducing reliance on rare earth materials. Imagine a world where we don't need to mine rare earth elements, but instead use waste materials to create super strong metals. Future applications. How this changes everything. This breakthrough isn't just for labs. It has real-world applications that could revolutionize multiple industries. Ultra-lightweight structural components. Perfect for aerospace, automotive, and construction. Next-gen magnetic alloys. Stronger and more sustainable alternatives to rare earth magnets. High-performance industrial tools. More durable, heat-resistant, and efficient materials. The possibilities are endless, and we're just scratching the surface. For decades, we've seen corrosion as a problem, but today, we're turning it into the solution. By harnessing corrosion, we're unlocking a new era of metal design lighter, stronger, and truly sustainable. So what do you think? Could this be the future of alloy manufacturing? Let us know in the comments. Don't forget to like, subscribe, and hit that bell icon for more mind-blowing science and tech discoveries. Stay curious, stay innovative, and keep pushing the boundaries of what's possible.